All right, 11.6. Here we go. The last section of Unit 11. So far, we've been mainly talking about angles and how do we measure central angles, inscribed angles, angles that are on the outside, angles that are on the inside when it doesn't pass through the center of a circle. But in this section, we're going to focus on the segments, the actual chords inside these circles, and how do we measure the length of the chord when it does not pass through the center of the circle. Okay. This section is not too difficult, especially when we have two chords that intersect on the inside of a circle. All we have to do is we have to multiply the two sides of the chord. So this x and this 24, they belong to the same chord. So we're just going to do 24 times x. And then what we do is we set it equal to the product of the other chord. So 21 and 16 make up the lengths on the other chord. So we'll multiply those two together. 21 times 16. Right? We just set these two terms equal to each other. So 21 times 16 is 336. So we have 24x equals 336. And then all we need to do is divide away the 24. And what we have is x equals 14. Okay? So whenever we multiply two chords together, we should have a constant number inside of a circle. So 24 times x is always going to equal 21 times 16. Right? So just take the two numbers on the same chord, multiply them together, and set them equal to the two numbers that multiply on the other chord. Now, on this next one, a little bit different because the chords, or I guess the secants in this one, they go outside of the circle. These have a little bit different of a relationship. What we need to do on this one is we're going to take this number on the outside. So this outside segment, what we need to do is we have to take that and we have to multiply it to this entire chord right here. So if you look at this entire chord, we just need to add these two things together. So that gives us 5 plus x minus 5, which if you notice, that just simplifies down to x. So what we do is we take this outside chord and we're going to multiply it to this entire segment here, which in this case it's simplified down to an x. So we're going to have 5 times x. And what we do is we set that equal to, we're going to do the same process on the other side. So we just look at just this outside segment and we multiply it with this entire secant right here. So that gives us 6 plus x minus 8, and that simplifies down to x minus 2. So we're going to have 6 times x minus 2. That is our expression. So we do the outside segment times the entire secant equals the other outside segment times the other entire secant. So what we have is 5x equals 6x minus 12. And then we do a little bit of algebra from there. We add the 12 to both sides, we subtract 5x from both sides, and we have x equals 12. Okay. Now, the third type is when we have a secant and a tangent. So remember, a secant passes a circle in two spots, where a tangent only passes in one. So this is going to be similar to the secant-secant scenario, except what we have is we are going to take this outside part, so this x plus 4 segment, x plus 4, and we multiply it with the entire part here. So we add those two together, so x plus 4 plus 5, 5 plus x plus 4, that simplifies down to x plus 9. So we have x plus 4 times x plus 9. What we do is we set that equal to, okay, now on this one, we only have an outside secant. I'm sorry, we only have an outside tangent. So we're going to take that outside segment here, that x plus 6. We just do x plus 6 again. Okay, if you wanted to think about it, if I had to label these segments A, B, and C, our setup on this one would be B times A plus B All right, we set that equal to c squared. Right, x plus 6 times x plus 6. Another way of writing x plus 6 times x plus 6 is x plus 6 squared. But whenever we have something like that, I really like to write it out. I really like to expand it out so we have these two terms, because a lot of people see that squared, and then that's where mistakes start to happen. So if you get this x plus 6 squared expression, that's fine. Just remember that it's really a good idea to go ahead and expand that out into x plus 6 times x plus 6. All right. But anyways, let's just FOIL this out and see what happens. We have x squared plus 13x plus 9 times 4 gives us 36 equals x squared plus 12x plus 36. All right. So let's just simplify this. Luckily, the x squareds cancel on this one, so we don't need to worry about factoring. And let's just subtract 12x on both sides, and then subtract 36 from both sides. Well, the 36s cancel each other out as well. So what we're left with is x equals 0. All right, now keep in mind, that's fine. Right? We are allowed to have x equals 0. All we have to do is just plug it back in. So this side is a 5. This turns into a 4, so we'd be left with 4 times 4 plus 5. Does that equal 0 plus this is 6? Does that equal 6 squared? Right, 4 plus 5 is 9, so that gives us 4 times 9. Does that equal 36? Well, 4 times 9 is 36. Okay, so it works. So x equals 0 is the correct answer. All right, almost done. So this is another situation where we have an intersection of chords inside of the circle. So we need to do x minus 3 times x minus 2. Okay, now let's set that equal to the other one, 6 times 15. So go ahead and FOIL this out. That gives us x squared minus 5x plus 6 equals 80. So quadratic, we have a trinomial. Let's move that 80. Oh, that's not 80, that's 90. Let's try that again. X squared minus 5x, let's subtract the 90 over, that gives us minus 84. Okay, so we need to think of factors of 84. Okay, this whole thing equals 0, so let's set these factors equal to 0. Which one of these, when we add them together, any combination of positives and negatives, would give us a negative 5? Well, if you look at 7 and 12, if we had a negative 12 and a positive 7, that would work. We have an x and an x, right? X times x makes x squared. Let's put our 12 here and our 7 there. Now, since this second sign is negative, the only way for us to get a negative product is when one of these is positive and one of these is negative. So the signs have to mismatch. So in order for us to figure out which one needs to be positive, we look at the first sign. All right, the first sign is negative. That means the bigger of the two numbers need to be the negative. All right, so set those both equal to 0. We have x minus 12 equals 0. Therefore, x equals 12. We have x plus 7 equals 0. Therefore, x equals negative 7. All right, so keep in mind, it's okay to have a negative x value, but sometimes it doesn't work and we just have to plug it back in. Right? If we plug that back in, this would give us negative 7 minus 3. Negative 7 minus 3, that gives us a chord length or a segment length of negative 10, and we can't have negative segments. That doesn't make any sense. Therefore, in this problem, x equaling negative 7 does not work. All right, 2 more. So this is the situation where we have a tangent and we have a secant. So what we need to do is we need to do x, the outside segment, times the sum of these two times the entire segment. So that gives us x plus 5. And since we have a tangent here, there's no other inside segment here, we need to square that tangent. So that gives us x squared plus 5x equals 36. We're going to take that 36 and move it over. That gives us x squared plus 5x minus 36 equals 0. Let's go ahead and factor this again. So we have an x and an x. We're going to do a 9 and a 4 because 9 times 4 makes 36. And if we have a positive 9 and a negative 4, that gives us our positive 5. So we have x equals negative 9, setting that equal to 0 and solving it. X equals negative 9 and x equals positive 4. Now keep in mind, if you plug in negative 9, you're going to have a segment length of negative 9. That doesn't make any sense. So that's an extraneous answer. And we are left with x equals 4. All right, last one. We have a secant and a secant. So let's take this outside segment, 7 times. So the segment times the entire secant, 7 plus 17, that gives us 24. Okay, let's set that equal to this segment, so x plus 2, times the entire secant. So adding those together, that gives us 3x plus 3. Okay, so times 3x plus 3. 7 times 24, that just gives us 168. Let's go ahead and FOIL this out. I want to do all that in one go. So let's go step by step. That gives us 3x squared plus 3x, 6x plus 6. All right, go ahead and combine your like terms. 3x squared plus 9x plus 6. All right, so let's see. Let's move the 168 over. We have 0 equals 3x squared plus 9x minus 162. All right, so we can either factor it now or we can make life just a little bit easier. Every single one of these numbers is divisible by 3. So what we can do is divide both sides of our equation by 3. And what we're going to have is x squared plus 3x minus 162 divided by 3 gives us 54. That whole thing equals 0. All right. Factoring is a lot easier when your leading coefficient is a 1. This will factor, but it's just going to be a little bit more difficult. So let's try to make it easy when we can. So let's go ahead and factor this. We have an x and an x. Factors of 54 that add up to 3. Let's try a 9 and a 6. All right, since 54 is negative, one of these numbers has to be negative, one has to be positive. Since the sign on the inside, or since the first sign is bigger, that means the bigger number, I'm sorry, since the first sign is positive, that means the bigger number needs to be positive. So we have x plus 9 equals 0, therefore x equals negative 9. We have x minus 6 equals 0, therefore x equals positive 6. All right, now we can plug both of those in to see if it works, but if you plug a negative 9 in here, negative 9 plus 2 would give us a negative 7, and we cannot have a negative segment. So x equaling negative 9 does not work. All right? So I'll leave it to you to plug in x equals 6 to see if that one works.